In compounds, hydrogen are single atoms with atomic mass 1.
In gaseous state, hydrogens are diatomic molecules, molar mass 2 grams per mole.
Let's solve this. A hydride has a vapor density of 15 and contains 20% of mass of hydrogen. Calculate the molecular formula of the hydrocarbon. Already we know that density is mass over volume. We're talking about the vapor density, mass of the volume of gas, all over mass of equal volume of hydrogen. Mass of gas, or mass of volume of gas, all over mass of equal volume of hydrogen. So vapor density is just telling us the relationship or the ratio between the mass of a given volume of gas with respect to the mass of an equal volume of hydrogen. So when you understand the concept of vapor density, you'll be able to find out how to find the molar mass of the gas. Now we know that hydrogen atom has an atomic mass of just 1. It has a atomic mass of 1, but in terms of a gas, it exists in molecular form. As such, it has to be given as 1 times 2. So hydrogen is 2. But vapor density, according to the question, is already given as 15 here. So that means that since our vapor density is 15 and our mass of equal volume of hydrogen is 2 here, what do? Cross multiply. So to get mass of gas, it will be, or molar mass of gas, however you want to put it, it will be 2 times vapor density. This is 30 gram per mole. It has been established that the hydride has a molar mass of 30 gram per mole. You know, the hydride is made up of hydrogen and carbon. Of course, the examiner could decide to say, okay, a carbon hydride. But of course, you know that talking about gases, it definitely won't be sodium, it definitely will be calcium.
In compounds, hydrogen are single atoms with atomic mass 1.
In gaseous state, hydrogens are diatomic molecules, molar mass 2 grams per mole.
Yeah, we're talking deliberately about carbons. Now, what's the mass of hydrogen here and the mass of carbon in the gas? Because the gas is 30 grams per mole. This is the hydride, but we want to split it into hydrogen and carbon. Now, it tells us that the gas contains 20% of mass of hydrogen. So we find 20% of this, 20% of 30 grams. This gives us, if we cancel through, this gives us 6. So it says 20% of mass of hydrogen. So that means we have 6. Then 6 out of 30, we've got 24 left. So the mass of carbon is 24, while hydrogen is 6. To expand your knowledge, you could also know that apart from gaseous hydride and metal hydrides that we pointed out here, you could also have non-metal hydrides like this, ammonia, water. As long as it contains hydrogen, it's an hydride. It's a hydride, so to speak.
In compounds, hydrogen are single atoms with atomic mass 1.
In gaseous state, hydrogens are diatomic molecules, molar mass 2 grams per mole.
Now, since we all know that number of moles is given as mass all over atomic mass. Mass all over atomic mass. So, since we've splitted these two individual atoms, this will be divided by 1 because that's the atomic mass for hydrogen. The atomic mass for carbon is 12. So this is divided by 12. Remember, mass all over atomic mass. Don't get it twisted. Hydrogen atom has a mass of 1 gram. Hydrogen gas, if it is gas, it doesn't exist singly, it will be times 2. Hydrogen atom weighs 1, while hydrogen gas has a mass of 2. For hydrogen atom, 1 gram per mole. For hydrogen gas, 2 grams per mole. But now it's been split to individual atoms. Therefore, you're going to use 1. No, 6 divided by 1 is 6. Right? 6 divided by 1 is 6, while 24 divided by 12 is 2. So number of moles for hydrogen is 6, while for carbon is 2. So the ratio of carbon to hydrogen is 2:6, which is equals to 1:3. C is 1, H is 3. So the empirical formula will be CH3 for the empirical formula. So C here is 12, H here is 1, that's for atomic, for hydrogen times 3, which gives us 3. So 12 plus 3 gives us 15. So CH3 weighs empirically 15 grams. But remember that the question from here we got 30 grams per mole. So that's going to be 2 of this because we got 30 here. So this is 30 grams per mole, and then from the empirical formula we're getting 15. This multiplies 2 to give us that 30. For it to multiply 2, you can rewrite it as CH3 2. This is also the same thing as C2H6. So what gas is C2H6? That is purely ethane. So this is our empirical formula, while our molecular formula is C2H6. It is from our empirical formula we got our molecular formula, because we told our molecular formula here, our mass of the gas was 30 grams, and then now that we are having 15, after doing our calculation, in order to get 30, you have to multiply by 2, and then that gives us an idea that this is exactly ethane.
In compounds, hydrogen are single atoms with atomic mass 1.
In gaseous state, hydrogens are diatomic molecules, molar mass 2 grams per mole.